So the chain rule is the most common one, the most common rule that will be used. Okay. You need to be able to use it all the time, and every single quotient rule, product rule question will most likely have some sort of chain rule, and that's where you'll forget Sam. Close your screen and focus up here, okay? So what I'm going to get you to do is really do it properly, long way, for multiple times, and then you can do it shorthand later. You do it shorthand later, what's going to happen? You're going to mess it up, okay? Just like expanding brackets, you're going to mess up expanding brackets. But this is the composite rule or the chain rule, okay? This looks pretty tricky, eh? What this is it's a function, g, within this other function of f, okay? That's what it's talking about. We're not going to use that notation. We're going to use this notation to start with, because what do you notice about the du's there? Yeah, okay, again, it's not exactly what happens, but at least you can sort of see it. So ultimately, this is something that we might have to differentiate. Okay, y equals sine of x squared. And hopefully you can see there that we're going, oh, we've got this function here within this function there. Okay, we haven't done trig ones yet, so we're not going to do trig ones. We can do just simple polynomial ones, like this one here. Can you see the function within inside the other function? Yep. So what we're going to do is say, right, we're going to say y equals u to the power of 2, because I'm going to say u is equal to 4x plus 3. Did everyone see that? Yeah. Yep. Can you see why I said 4x plus 3? Yep. So now what we can say is we can differentiate y with respect to ua. What's dy by du? Yeah, that's not hard, eh? That's pretty straightforward. What's du by dx? 4. Yeah, remember this bottom line, when we're differentiating, means with respect to. So with respect to u, that's the one where we bring down the power and take one off the power. Okay? So if we've got dy by du is 2u and du by dx is 4, then what we can say, because dy by dx, that's what we're trying to find, we can use this chain rule to multiply both of those together. Because as we sort of said before, the du's could cancel. How do you get 4? Just the coefficient of x. Okay. That's just a straight line with a gradient of 4, y-intercept of 3. Okay. That's probably one of the first ones you did last year. But don't try and overthink too much of those. If I asked you what's the derivative of, what's that answer? Where'd the 4 come from? It's because it's the coefficient of the x. Okay. So this just becomes 2u times by 4, which is 8u, isn't it? But what's u? So we're going to say, so dy by dx is 8 lots of 4x plus 3. Okay? Happy with that? There's your answer. And some of you will do this enough, you can go, oh, I can sort of see where the 8 4x plus 3 comes from. And we'll get there eventually, but not at the moment.
Would you not then do 8 times 4x?
I wouldn't. No.
Because that's still like the answer.
Yeah. Because why else do we use, why do we differentiate?
Find the gradient.
Find the gradient. Can you find the gradient when x is 3 here?
Yeah, no.
Yeah, you substitute x, don't you?
I don't understand this video.
Can you find the gradient if x is 2?
Yeah.
You just chuck in 2 there. 4 lots of 2 is 8 plus 3 is 11 times by 8. Yep. Why else do you differentiate?
To find what do you call it? Vertex.
Yeah, to find the turning points, eh? And to find a turning point, generally speaking, it's easier when it's factorized. Okay, that's the main thing. So, like last year, you could have expanded that bracket and done it properly, but this year, we're not going to be wanting to expand to the power of 5, or to the power of 5, or something like this here, where it's on the bottom line. Okay, so I can go through a few more examples while we're doing the video. Hopefully, you can sort of see what's going on here. So what I would do is I'm going to write it as y equals this. Why am I writing with y equals?
So then you can use the x and b.
Yeah, so it's just that notation. Okay, does y and fx would we interchange?
Yeah.
Okay. So what am I going to do here?
Make u equal x cubed minus 3.
Yeah, I'm going to say u is equal to x cubed minus 3. So that makes y equal to u to the power of 5. You happy with that?
Yeah.
So let's go. Dy by du is equal to 5u to the 4. Du by dx is equal to 3x squared. So dy by dx, which is dy by du times by du by dx, is equal to 5 lots of u to the power of 4 times by 3x squared. Happy with that? Is that my answer? What do I do? Chuck in u. And I could probably put this 3 and the 5 together as well. So I could make that 15x squared x cubed minus 3 to the power of 4. Okay? Can you see now why don't expand them out? Because you still potentially have to expand out 4 brackets. Happy with that? Can we see the answer there? Who can see the shortcut? Can anyone see the shortcut yet? Good. Good. All right. 2 more examples and then we'll stop the video. Because these ones are more likely ones you're going to see. So what are we going to do here?
U equals 5x.
Yeah, because you can't differentiate when you use them when you get to them in the denominator, right? We're going to take those to the top line, right? So we're going to go, let's let u equal this 5x plus x to the power of 4, which that makes y equal to 2 lots of u to the minus 1. Can you all see that? Yep. So dy by du is going to be negative 2 u to the minus 2. Happy? This one here, du by dx is equal to 5 plus 4x to the power of 3. Yep. So dy by dx is simply that one times by that one. Yep. Which hopefully you can sort of see. I'm going to put that in brackets. That's going to become negative 2 lots of
Sorry, how did you get y?
I'll go back to y in a second. Yep. I've just said y is that there. Do people follow that or not? Did I not say that wrong? Yep. And then remember what we did yesterday. If I've got y equals 2 over x, how do I differentiate that from yesterday? What you say the day before? Yeah, I take that negative. I take the x from the denominator, put it to the top, and make it a negative 1. The power of negative 1. Is that my answer though? What do I do? Chuck in u, yeah. So it's going to become negative 2 lots of 5 plus 4x to the power of 3 all over u squared. So you can automatically see these are getting much bigger, right? They're much bigger.
How did you get that?
This one here? So that, if you can follow this process here, that one there is the same as y equals 2 to the x minus 1. Then I'm just putting that there down to the denominator, and I'm combining that, and that is my numerator. Okay? You can see how it's going to get trickier, right? You can hopefully see why I feel like writing du by dx, dy by du is going to be useful. Yeah. This last one here, before I stop the video and we can have a crack at it, that last one there, what are you going to do? So, u equals x cubed minus 2. So what does y equal?
U to the half.
Yeah, u to the power of a half. Do you guys want to have a crack? So hopefully you got there after the pause. Hopefully you got there. Remember, once you get there, it's not as simple as saying, oh, that's just... Because that is the same as 1 over 2u to the power of a half times by 3x squared. Hopefully you can see that part there, the fact that that u to the minus a half goes on to the back to the denominator, because the negative on the top line of the power goes to the denominator. For this one here, we've got to substitute in, so it's going to be 3x squared over 2 lots of u, which we said was x cubed minus 2 to the power of a half. Okay? That's the sort of thing we need to be able to do. Yep. From there, we need to be able to solve, like find the gradients of those functions, by substituting in x's. We need to be able to differentiate those to solve where that graph has a turning point or a point of inflection, as there is in year 13. But first and foremost, we need to be able to differentiate those. Okay, and that's the chain rule. Hopefully the chain rule will become much easier over time and you can sort of see the shortcut later on. But at the moment, what we need to do, we need to write this part here out, write that part there out, differentiate it. I would even say that part there is pretty useful just to get to the habit of doing that to start with. Okay, and then writing down that stuff there. That's your sort of your process you need to be able to do. Okay? Any questions with that?